My name is Soyan. We will be presenting the data governance application in business analytics, focusing on Grab Holdings. The Digital Asia Hub reports highlight poor data governance leads to inaccurate insights, inconsistent reporting, and ultimate flawed business decision. So for this assignment, we choose Grab Holdings as our case study. Grab is Southeast Asia's largest super app, processing over 10 million transactions daily across ride-hailing, food delivery, and finance services. This makes its data ecosystem both complex and highly instructive for our analysis. Let's look at Grab's background. The company was founded in Malaysia in 2012 as MyTaxi, with a simple mission to make transportation safer and more accessible, especially for women. Today, Grab is a super app with over 44 million monthly users across 8 countries. It employs more than 2,000 technology professionals and is valued at over $20 billion as of May 2025. Grab main operations span mobility, deliveries, financial services, mapping, and advertising. Its business model is a multi-sided platform that connects consumer driver partners, merchant partners, and advertisers, creating a rich and interconnected data ecosystem. Grab manages a petabyte-scale data infrastructure across multiple verticals. The key data sources include user data such as demographic and location, transaction data from ride bookings and GrabPay payments, driver data like earnings and ratings, and geospatial data from Grab Maps. They also collect merchants' data like menus, inventory, behavioral data from clickstream interactions, financial data such as credit scores and loan history, and logistic data including routes and ETA. Each of these data types plays a critical role in Grab's analytics and decision-making processes. Moving on to predictive analytics and data governance, artificial intelligence is central to Grab missions of delivering personalized experience. Key analytics applications include trends predictions to identify at-risk user, demand forecasting to optimize driver location, fraud detection for real-time transaction monitoring, personalized recommendations, ETA predictions, dynamic pricing, and credit underwriting. Grab also delivered MindStep at an AI-powered copywriting tool that achieves 25 to 50% higher engagement and 98.5% reduction in the content creation time. However, data governance is what makes all of this possible. Grab previously faced weaknesses including gaps in data ownership, which lead to duplicate pipelines and the absence of single source of truth. With undetermined confidence in analytics, governance is critical for 3 reasons. First, regulatory compliance with PDPA and bank legal requirements. Second, platform trust, as Grab reported zero data breaches in 2025 and hold DPPM certifications. And third, AI reliability, because machine learning models depends on clean, well-governed data. So the good news is, Grab is seeing measurable improvement after implementing a data mesh architecture. Today, 75% of query now hits certified assets. There's been 400% increase in deprecable tables, meaning redundant data is being cleaned up, and there's 58% reduction in P80 datasets, showing convergence towards the most trusted data source.
Next, I will present the data lifecycle management analysis of Grab. Data lifecycle management is the process of managing data throughout its lifecycle to ensure the quality, security, accessibility, and regulatory compliance of data. Grab data lifecycle consists of 8 phases. The first phase is data generations, where Grab generates user and also driver data, transaction record, and also GPS information through the Grab maps. The second phase is data collections, where these data are collected through Grab mobile application, GPS tracking, payment system, and also merchant dashboard. The third phase is data processing, where Grab use ETL pipelines and also real-time streaming technology to clean, transform, and also prepare the data for analysis. The fourth phase is data storage, where processes data is stored in MySQL database, data lakes, and also cloud platform for future access. The fifth phase is data management, where Grab manage and also organize its data through the Signal marketplace, and also allowing data to be shared and also accessed across different business teams. The sixth phase is data analysis, where the AI, machine learning, and also data analytics are used to identify the pattern, understand the customer behavior, and also support business decision. The seventh phase is data visualizations, where the analyst results are presented through dashboards and also reports to help the manager monitor business performance. Finally, the eighth phase is the data interpretations, where these insights are used to support business decision and also strategy planning. Although Grab has a strong data infrastructure, it still faces several challenges. First, the large volume and also variety of data makes the data management become more complex. Second, duplicate data pipelines may occur when different teams create similar data sets. This will lead to inconsistent information. Third is the poor data ownership. This will reduce the accountability for maintaining the data quality. And finally, communication gaps between data producer and also consumer may result in incomplete or inconsistent data. This weakness can lead to the lower data quality, inconsistent analytics, less reliable dashboard, and also poorer business decision. In conclusion, effective data lifecycle management is essential to ensure high-quality data, reliable analytics, and also informed business decision-making. Thank you.
This let's present our proposed data ownership structure for Grab. Different types of data are assigned to the teams that use and understand them best. For example, customer data belongs to the CRM teams, transaction data to finance, driver data to driver operations, and advertising data to marketing analytics. Having clear ownerships allows each team to define business rules, KPIs, and data definitions for their own domain. This creates clear responsibility and forms the foundation for effective data governance. Besides data owners, data stewards ensure data quality by checking for duplicate, missing or outdated data and maintaining consistent data standards. Data custodians manage the technical side, including secure storage, access control, encryption, and reliable data pipelines. Together with data owners, data stewards, and data custodians ensure high quality, secure, and consistent data, providing a strong foundation for reliable analytics.
For accountability, Grab should use a data quality scorecard for every major data source. This scorecard checks completeness, accuracy, timeliness, consistency, uniqueness, and validity. For example, transaction data should have complete order IDs and payment status, while logistic data should have near real-time GPS updates. Grab should also have a clear escalate process. When the data steward finds a problem, it should be recorded in the ticketing system. The data custodian then investigates whether the issues come from the system, API, database, or data pipeline. The data owner decides the business priority and approves the major changes. Before dashboard or predictive models are used, the data owner should sign off the definitions while the data steward verifies data quality. Overall, this improves data quality, consistency, and analytics reliability, helping Grab make better decisions.
Now, I will be presenting the data governance policy. First is the data access policy. Grab should implement role-based access control so employees can only access data related to their job responsibility. In addition, every asset request should be approved by a data owner and recorded in audit log to improve security and accountability. Next is the data privacy policy. Since Grab collects sensitive information such as personal details, payment record, and GPS location, it should be complied with the Personal Data Protection Act. Personally identifiable information should be anonymized before being used for analytic, and customer content should always be obtained when collecting or sharing personal data. The final policy is data security policy. Grab should encrypt sensitive data, enable multi-factor authentication, perform regular backup, and continuous monitor its system to prevent cyber threats and protect business data. Moving on to the data governance standard, Grab should establish a centralization data dictionary to ensure consistent business definition across all departments. It should also maintain standardized metadata such as data owner, source system, and data lineage to improve data management. Finally, data quality should be measured based on 6 dimensions: completeness, accuracy, consistency, validity, timeless, and uniqueness.
After establishing a governance policy and standard, Grab also need continuous governance process to ensure they are effectively implemented. There are 3 key processes. First, data validation check customer, driver, and transaction data before it enters the system by identifying missing value, duplicate record, and invalid format. Second, data monitoring continuously monitor data quality and operational pipeline in real time, allowing issue to be detected and corrected quickly. Finally, data auditing review compliance with governance policy, data standard, and privacy regulation. Together, this process helps Grab maintain accurate, reliable, and high-quality data throughout its data lifecycle. With high quality and trusted data, Grab can perform business analytics more effectively. For example, accurate transaction and customer data improve the demand forecasting, while the reliable real-time operation data support dynamic pricing and route optimization. In addition, high-quality financial data enhance fraud detection and strengthen the regulatory compliance. Overall, the proposed data governance framework improves the data accuracy, consistency, and reliability, enabling the better analytic and more informed business decisions. So that's all of our presentations. Thank you for watching.